DevOps specialists who can assist companies in navigating the complex, fast-paced world of software development and IT operations are in high demand today. DevOps is providing numerous job opportunities. According to the latest Glassdoor report, the average salary for DevOps engineers is Rs 7,70,000 per year in India. The average salary for DevOps engineers is around $108,000 per year in the United States. Accenture, TCS, IBM, Cognizant, and HCL Tech are the top companies hiring for DevOps engineer roles. If you have a passion for technology, enjoy solving problems, and thrive in a collaborative and dynamic environment, a career in DevOps can be a rewarding choice. Today, let's explore what DevOps is, the DevOps Lifecycle, and the problems solved by DevOps, followed by how companies use DevOps. Next, we will cover the roles and responsibilities of a DevOps engineer, along with some common tools used by them. Finally, we will discuss the roadmap for a DevOps engineer position. So before we get started with the topic, please consider subscribing to our YouTube channel and hit the bell icon to stay updated on the latest tech content by Edureka. Also, visit the Edureka website for training and certification courses, the link to which is in the description box below. So what is DevOps? Before we get into how to become a DevOps engineer, let's explore what is DevOps and who is a DevOps engineer. So DevOps is a set of practices that aims to automate and integrate the processes of software development and IT operations. The term DevOps is a combination of development and operations, reflecting the collaboration and communication between these two traditionally separate teams. In 2008, the term DevOps was officially coined by Patrick Debois, a Belgian consultant, and Andrew Schaffer, a system administrator. The concept of DevOps emerged as a response to the challenges and inefficiencies that arose from the traditional approach to software development and IT operations. DevOps Lifecycle. So, the adoption of DevOps practices often involves a series of interconnected activities that span the entire software development and IT operations lifecycle. The DevOps lifecycle is characterized by continuous feedback, collaboration, and the iterative improvement of processes. This is a generalized representation of different phases of the DevOps lifecycle. Plan. In the planning phase, development and operations teams collaborate to define project goals, set priorities, and plan the features and improvements to be delivered. This phase involves aligning development efforts with business objectives and determining the necessary resources. Code. The coding phase involves developers writing and committing code to version control systems. Collaboration and communication between team members are crucial during this phase. Continuous integration practices ensure that code changes are frequently and automatically integrated. Build. The build phase involves compiling the code, running automated tests, and creating executable binaries. This process is often automated through continuous integration tools, ensuring that the software is built consistently and tested thoroughly. Test. Continuous testing is an ongoing process throughout the DevOps lifecycle. It includes unit testing, integration testing, performance testing, and other tests to verify the functionality, security, and performance of the software. Automated testing is a key aspect of identifying issues early in the development process. Release. The DevOps department prepares updates or sends several versions to production when the build satisfies all checks based on the organizational demands. In the release phase, the primary goal is to ensure that the environment is set up for a successful launch of the updated software. Deploy. In the deployment phase, validated changes are automatically deployed to production environments. Continuous delivery practices ensure that software changes are ready for deployment at any time. Operate. The operate phase involves monitoring the performance and health of applications and infrastructure in real time. Continuous monitoring provides insights into system behavior, allowing for proactive issue detection and resolution. Automated scripts may be used to manage and maintain infrastructure. Monitor. Continuous monitoring and logging are essential for capturing data on system behavior user interactions, and performance matrices, monitoring tools provide visibility into application and infrastructure health, enabling teams to make data-driven decisions and respond to issues promptly. Problem solved by DevOps. So DevOps evolved as a solution for the challenges in the waterfall and agile models. DevOps addresses various challenges and problems that organizations face in the process of developing, deploying, and maintaining software. Here are some key problems solved by DevOps practices. Slow software delivery. Traditional development and operations processes are often slow with lengthy release cycles. DevOps introduces automation, continuous integration, and continuous delivery practices to speed up the software delivery pipeline, allowing for faster and more frequent releases. Frequent software failures. So, inconsistent and manual deployment processes can lead to errors and failures when deploying new software. DevOps automates deployment processes, reducing the risk of human error and ensuring more reliable and consistent releases. Continuous testing also helps catch issues earlier in the development lifecycle. Lack of collaboration. So, traditional silos between development and operation teams result in poor communication and collaboration. DevOps promotes a culture of collaboration and shared responsibility. Cross-functional teams work together throughout the entire software development lifecycle, fostering better understanding and communication. Inefficient resource utilization. Manual and time-consuming processes lead to inefficient use of resources. Automation in configuration management, infrastructure provisioning, and scaling enables efficient resource utilization. So this results in cost savings and improved overall operational efficiency. Poor infrastructure management. Manual infrastructure management can lead to inconsistencies and difficulties in scaling. So DevOps practices, including infrastructure as code, automate the provisioning and management of infrastructure. This ensures consistency and makes it easier to scale resources as needed. Security concerns. Security is often treated as a separate concern and is not integrated into the development and operations processes. DevOps integrates security practices into the entire software development lifecycle, addressing security concerns early in the process and reducing vulnerabilities. Companies using DevOps. Companies across various industries have adopted DevOps practices. It's important to note that the use of DevOps is not limited to a specific sector, and organizations of all sizes, from startups to enterprises, can benefit from its principle. Some examples of companies that were known for their DevOps adoption are Amazon. Given its focus on cloud computing with AWS, that is Amazon Web Services, Amazon has been a pioneer in adopting DevOps practices to enhance its service delivery and infrastructure management. Netflix. Netflix is renowned for its use of DevOps and cloud technologies to support its streaming services. The company emphasizes automation, continuous delivery, and a culture of innovation. Google. Google, with its site reliability engineering practices, aligns closely with DevOps principles. SRE is Google's approach to running large-scale reliable services. Spotify, known for its music streaming service, utilizes DevOps practices to support its agile development and continuous delivery. The company organizes its development teams around the squad model. LinkedIn. LinkedIn is a professional networking platform, has implemented DevOps practices to enhance collaboration between development and operations teams and ensure the reliability of its services. Adobe. Adobe has adopted DevOps to improve its software development processes, allowing for faster releases and better collaboration between teams. Now let's move on to the roles and responsibilities of a DevOps engineer. A DevOps engineer is an IT professional who combines software development and IT operations to enhance the efficiency and teamwork of an organization's software development and delivery process. They should ensure fast, reliable, and secure software delivery. A DevOps engineer is responsible for creating scripts and tools to automate various aspects of the software development process, such as code integration, testing, and deployment. DevOps engineers frequently work with infrastructure that's managed through code and act as cloud architects. DevOps engineers also carry out quality assurance software testing to understand the effectiveness of various software tools. They put in place mechanisms to monitor the functionality of applications and gather logs in order to identify and fix problems. Now, let's move ahead with some common tools used by a DevOps engineer. Version control. Widely used for source code version control, Git is the backbone of many DevOps workflows. Git is used to monitor changes in the source code, enabling multiple developers to collaborate on non-linear development. CI/CD. Continuous integration, continuous deployment is a technique that involves automating different stages of app development to regularly deliver apps to customers. Some popular CI/CD tools are Jenkins, an open source automation server that supports building, testing, and deploying code. GitLab CI, integrated CI/CD solutions tightly coupled with version control platforms. Travis CI, a cloud-based CI/CD service that integrates with GitHub repositories. Configuration management. Ansible, an open-source automation tool for configuration management, application deployment, and task automation. Chef, an automation platform that manages infrastructure as code. Containerization. Docker, a platform for containerizing applications, is the most widely used container technology available today. A Docker container image is a lightweight, standalone, executable software package that includes code, runtime, system tools, and system libraries. That is everything needed to run an application. Orchestration. The deployment, scaling, networking, and management of containers are all automated with the help of container orchestration. Kubernetes is an open source platform for container orchestration that automates containerized application deployment, scaling, and management. Infrastructure as code. Terraform. Terraform is the most popular infrastructure provisioning tool. It is a tool for building, changing, and versioning infrastructure as code. CloudFormation. Amazon Web Services native IAC tool for defining and provisioning AWS infrastructure. Cloud platforms. Public cloud platforms such as AWS, Microsoft Azure, and Google Cloud Platform offer a wide range of services for building and deploying cloud-based applications. Now, let's move on to answer to the question, how to become a DevOps engineer. So, becoming a DevOps engineer involves acquiring a combination of technical skills, knowledge of certain tools and practices, and most importantly, a mindset that emphasizes collaboration and automation. Step 1. Basic qualifications. The primary step to becoming a DevOps engineer is to make sure you meet the basic qualifications. A Bachelor of Computer Science or a similar degree that focuses on software development is the minimum requirement for a DevOps engineer. A postgraduate degree will be beneficial. Industry experience in roles that expose you to scripting and programming languages and experience in a leadership role may also be helpful. Step 2. Understanding of software development lifecycle. This SDLC represents the process through which software is planned, developed, tested, deployed, and maintained. DevOps engineers benefit from understanding the various phases of SDLC to effectively implement and support DevOps practices throughout the entire software development process. Step 3. Programming knowledge. Engineers are advised to be proficient in at least one programming language so that they can create automation scripts. Proficiency in programming languages such as Python, Go, and JavaScript is imperative for task automation and tool development. The language Python has multiple paradigms. Because it is an interpreted language, code can be written in a variety of ways and is executed immediately. Python's emphasis on readability, consistency, and ease of use makes it a popular choice for new coders to learn first. The fundamentals of programming languages, including the syntax, if-else, loops, data structures, etc., must be learned in this case. Step 4. Linux and scripting. Automation is the base of DevOps, and scripting is crucial for tasks like configuration management and deployment automation. An operating system acts as a link between the user and the hardware of a computer. Since the majority of servers run Linux OS, you must become familiar with Linux and its command line interface. Ubuntu is one easy-to-use distribution. It would help if you had a basic understanding of Linux fundamentals such as file handling, system administration, shell commands, and process management. Step 5. Version control. Develop your understanding of version control systems such as Git to monitor and manage changes in code and configurations. Here you will need to become familiar with Git commands such as git clone, branch, and merge. Step 6. Containerization and orchestration. Understand containerization concepts and technologies like Docker. Learn how to create, deploy, and manage containerized applications. You must understand how to use Docker networking, volumes, Docker files, and Docker Compose to run multiple containers. Container orchestration can be used in any environment that uses containers. It can help deploy an application across different environments without needing to modify it. Microservices in containers make it easier to orchestrate services such as storage, networking, and security. Here you need to learn how Kubernetes works, how to administer the Kubernetes cluster, and how to deploy applications on it. Familiarize yourself with container orchestration tools like Kubernetes. Kubernetes is widely used for automating the deployment, scaling, and management of containerized applications. 7. Cloud services. Cloud providers offer a layer of APIs to abstract infrastructure and provision it based on security and cost constraints. The great success of contemporary DevOps can be attributed to the cloud provider's ability to provision, configure, and secure resources quickly. A DevOps engineer should have cloud computing skills and should have an understanding of public cloud platforms such as AWS, Azure, or Google Cloud to deploy and manage applications. Here, you need to know how to manage users and administration, networks, virtual servers, etc. Step 8. Learn infrastructure as a code. Infrastructure as a code describes the methods and resources for defining infrastructure, usually in a markup language like JSON or YAML. Engineers can automate environment setup with infrastructure as code. Explore IAC tools like Terraform or CloudFormation and learn how to define and manage infrastructure using code. Here, you need to know how to do infrastructure provisioning and configuration management. CI/CD. CI/CD brings continuous automation and continuous monitoring to apps at every stages of their lifecycle, from delivery and deployment to integration and testing. These connected techniques are often referred to as CI/CD pipeline and are used by development and operation teams. So CI/CD is a solution to the problems that arise when integrating new code. So learn about CI/CD pipelines and tools like Jenkins, GitLab CI, or Travis CI. Here you need to learn how to set up CI/CD server, integrate code, and trigger pipelines automatically, and build management tools. Step 10. Networking and security. A network protocol is a set of rules that specify how data is transferred between different devices in the same network. It allows connected devices to communicate with each other despite any differences in their internal processes, functionality, or design. Here, you will need to know how a network works, how to configure firewalls, and understand the workings of DNS, OSI model, IP addresses, ports, etc. Step 11. Soft skills. Develop good communication and collaboration skills. DevOps involves close collaboration between development and operations teams. So effective communication is essential. You should also develop troubleshooting skills to resolve issues effectively. Try to improve monitoring skills by overseeing the development process from planning, deployment, integration, testing, and operations. Step 12. Certifications. Certifications are an important factor in standing out from other candidates and are useful in building up technical skills. Some in-demand DevOps certifications required for a DevOps engineer include AWS Certified DevOps Engineer Professional. So Edureka offers the AWS DevOps Engineer Certification Training course that improves technical expertise in provisioning, operating, and managing distributed application systems on the AWS platform. Second, Certified Kubernetes Administrator. Kubernetes certification training by Edureka is curated by top industry experts and will help you clear the official Certified Kubernetes Administrator exam. So this training is live and instructor-led and helps you master key Kubernetes concepts with hands-on demonstrations, which in turn helps you become a certified Kubernetes professional. Microsoft Certified DevOps Engineer Expert Certification. So Edureka's Microsoft Azure DevOps certification course is curated by industry professionals as per the industry requirements and demands. This Azure DevOps training gives you a solid foundation to appear for the Microsoft Certified DevOps Engineer Expert certification. Please check out the training courses offered by Edureka for these certifications. The link to these is in the description box below. Step 13. Showcase your skills. This last and final step is very important to land a DevOps engineer job role. Make sure to showcase your skills by creating projects, blogs, and videos or contributing to open source platforms. This public learning creates a positive impact for the recruiters. Today, DevOps is considered a fundamental approach to software development and IT operations, with organizations of all sizes implementing DevOps practices to improve collaboration, speed up delivery, and enhance the overall quality of their software. DevOps is a rapidly evolving field, so commit to continuous learning. Stay updated on new tools, practices, and industry trends. Remember that becoming a DevOps engineer is a journey that involves both technical and soft skills development. Practical experience and real-world projects are crucial for applying what you learn and building a strong foundation in DevOps practices. All the best for your DevOps journey. Make sure to like and subscribe to our YouTube channel. Thank you for watching and keep learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!